Hello guys. So today we are going to deal with a most interesting and an important chapter called as your surface chemistry. Of course, the title itself is indicating what we are going to study in overall in this chapter. Yes. So we are going to mainly deal with the chemistry which is involving the body surface. So first and foremost thing, let me ask you a question. For example, you take a white sponge. Okay, I'm very much particular about the sponge color, sponge kotala. Yes, white sponge. And you prepare a blue color solution. That is, you take some water, add one ink to it, blue color ink to it, and you prepare what? Blue color solution. Yes. Now what is your task is, you have to dip this white sponge to this blue colored solution and you have to remove it in a fraction of a second. Able to understand? You have prepared a blue colored solution. Yes, a very dark blue colored solution you have prepared, that is ink plus water. Okay. And what I'm saying is, you take a white sponge and you dip in the blue color solution and remove it in instant of time. Soon after you remove the white color sponge from this blue colored solution, what is your first observation? Yes, if this was your white color sponge and you have dipped this much portion in 1 second, of course what you could see, this part has been colored with which color? Blue color. So first is your observation. Second, what you do, as soon as you remove it and you watch the color, you have observed the color, now you just tear the sponge. You just tear the sponge. So what you could see, the inner part of the sponge, yes, it remains white itself. It remains white itself. Alba. So what is your task? You take a white color sponge, take a blue colored solution, you dip this white color sponge in your blue colored solution and you remove it at an instant of time and you just tear it. So what was the first observation? We have seen that whatever the exposed part of the sponge was there in this medium, it has turned to blue color, and when we tear it, we have observed that the inner part of the sponge is remaining white itself. That means what? It is just an example, okay, for the better understanding that what we are going to see in this chapter. So what is the conclusion we can draw? Whatever the particles were there, that is your blue colored particles were there, that has been only got stick to the surface of this sponge. So what were our conclusions we can draw? The conclusions what we can draw is, whatever the blue color particles were there, blue color particles were there, that has been only sticked on the surface of the sponge, sticked on the surface of the sponge. Yes, and it has been not penetrated. It has been not penetrated inside the body of the sponge. It has been not been penetrated inside the body of the sponge. So in our topic, we are going to understand that what it is happening over here. Yes, this was just a mere example I have given to you, for that we can better understand. So whatever we are going to deal is about the surface part. Why such a phenomenon is taking place on the surface? Now when the question is arising that we are dealing with the surface, of course there should be some process, some name should be there. Remember, so this overall surface chemistry has been dealt with a process or a phenomenon called as what? Remember, it is adsorption. AD, it is not AB, it is what? AD, adsorption. So what do you mean by this adsorption? Of course, whatever we have seen over here, we are going to write it in a technical terms. So how can you write it, the adsorption? Remember, It's a process. What it is? Adsorption is a process of what? Of accumulation. That means what? Concentrating. Accumulation. Accumulation of, yes, liquid. Please state the matter over here. I'm very much specific about my matters. Adsorption what? It is a process of accumulation of what? Liquid or gases. Liquid or gases on the surface of solid. On the surface of solid is called as what? Is called as your adsorption. Now let us deal by it once again. So what do you mean by now adsorption? Of course, now what did I give an example? You just recall it in your mind when you are reading this part. Adsorption is a process of accumulation of liquid or gases. So it ಏನಾಗ್ತಾ ಉಂಟು ಯಾವುದೋ ಒಂದು ಸಾಲಿಡ್ ಸರ್ಫೇಸ್ ಮೇಲೆ yes liquid ಅಥವಾ gas molecules coming and accumulating, that part or that process will be called as what? Your adsorption. Yes. So in the mere example, what I can consider, your sponge can be considered as what? The surface of the solid on which what is happening? Accumulation of your liquid is taking place. Alva. So that was the reason it could be called as what? Adsorption process. So adsorption process ಅಲ್ಲಿ we are dealing with all the three states of matter. Okay, it may be individually any two. ಯಾವುದೋ ಒಂದು process ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಸಾಲಿಡ್ ಪಕ್ಕ ಇದ್ದೇ ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಇದು ಸರ್ಫೇಸ್ ಮೇಲೆನೆ ಇಲ್ಲ ನಿಮ್ಮ ಲಿಕ್ವಿಡ್ ಬಂದು ಕೂರುತ್ತೆ, ಇಲ್ಲ ನಿಮ್ಮ ಗ್ಯಾಸ್ ಬಂದು ಕೂರುತ್ತೆ. ಇಫ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ ಸಮ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್, ಈಗ ನಾನು ಇಲ್ಲೇನ್ ತಗೊಂಡೆ, ಒಂದು ಸ್ಪಾಂಜ್ ನ ತಗೊಂಡಾಗ ಏನಾಯ್ತು, ಯಾವ ಎರಡು ಸ್ಟೇಟ್ ನ ನಾವು ನೋಡಿದ್ವಿ, ಸ್ಟೇಟ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್ ನ. ಅಫ್ಕೋರ್ಸ್ ನಿಮ್ಮ ಸ್ಪಾಂಜ್ ಇಲ್ಲಿ ಏನಾಯ್ತು, ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಆಯ್ತು. ಅದ್ರಲ್ಲಿ ನಿಮ್ಮ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಯ್ತು, ಲಿಕ್ವಿಡ್ ಫೇಸ್ ಆಯ್ತು ಅಲ್ವಾ. ಗ್ಯಾಸ್ ಫೇಸಿಗೆ ಹೋಗ್ತೀನಿ. ಇಟ್ ಇಸ್ ನಾಟ್ ದಟ್ ವಿ ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ರೀಡ್ ಇಟ್. ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಒನ್ ಆಫ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರೊಸೆಸ್. ಈಗಲೇ ಹೇಳಿದ್ರೆ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಬಟ್ ಫಾರ್ ಅ ಹಿಂಟ್ ಐ ವಿಲ್ ಜಸ್ಟ್ ಗಿವ್ ಯು ದ ಕೆಟಾಲಿಸ್ಟ್. Catalyst ಮೇಲೆ hydrogen ಕೂರೋದು, that is an example of a gases. We are going to study it, but just for a while you understand. What is that? Adsorption is a process of accumulation of liquid or ಅಂತ ಹೇಳಿದ್ದೀನಿ ನಾನಿಲ್ಲಿ. And ಅಂತ ಹೇಳಿಲ್ಲ, ಏನಂತ ಹೇಳಿದ್ದೀನಿ, it is or. Either any of the one can happen at a time. Process of accumulation of liquid or gases on the surface of this solid. So we need a surface of this solid for the accumulation to occur. So that process is called as what? Your adsorption. But now when I am using the terms in this adsorption, again and again I can't use liquid. Okay, liquid band kurta untu. Liquid is coming and sitting. No. Okay, gas is coming and sitting. So again and again I have to use these terms. So instead of that, in adsorption, we are giving two technical terms which will be useful overall in this chapter. One is called as what? Adsorbent. Please do remember, very important concept, adsorbent. And one more, it is called as what? Adsorbate. Adsorbent and an adsorbate. So first let us know that what do you mean by this adsorbent? Remember, it is the solid surface. What it is? It is the solid surface on which the process of adsorption is taking place. It is a solid surface on which the process of adsorption takes place. Process of adsorption takes place. What it is called as an adsorbent. Hagadre adsorbate, can you please help me? Yes. It is the liquid or gaseous species. It is a liquid or gaseous species which accumulate on the surface of solid. On the surface of solid is called as what? Is called as adsorbate. Adsorbate. Of course, alva nama adsorption process alli navu enanta nodidvi. It's a process of accumulation of liquid or gases on the surface of solid is called as what? Adsorption. So instead of using this solid, liquid or a gas, what we are giving it, a technical terms we are giving it. What is those? First and the foremost thing is an adsorbent. So whatever the surface of the solid you are taking for this adsorption process, alva, ಈ adsorption process ಮಾಡಕ್ಕೆ ಯಾವುದು ನೀವು ಸಾಲಿಡ್ ನ ತಗೊಂತಾ ಇದ್ದೀರಾ ಆ ಸಾಲಿಡ್ ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? adsorbent. ಸೊ ಆ ಸಾಲಿಡ್ ಮೇಲೆ ಯಾವ ಲಿಕ್ವಿಡ್ ಅಥವಾ ಗ್ಯಾಸಸ್ ಹೋಗಿ ಕೂರುತ್ತೋ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? adsorbate. Please do remember, you remember any one of this in order to avoid the confusion. ನೋಡಿ adsorbent ಅಂತ ಉಂಟಲ್ಲ, ಬೆಂಟ್ ಅಂದ್ರೆ ಸಮಥಿಂಗ್ ಸ್ಟ್ರಾಂಗ್ ಅಂತ. ಸೊ ಅವಾಗ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ, 3 ಫೇಸ್ ಅಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಯಾವುದು? ನಿಮ್ಮ ಸಾಲಿಡ್ ಪಾರ್ಟ್. So you just remember, adsorbent is a solid surface on which the process of adsorption is taking place. Another word is an adsorbate. It's a liquid or the gaseous species which is accumulating on the surface of the solid is called as what? Adsorbate. So these are the two important terms we are going to use again and again in our further classes. Of course, when I am using the word as an adsorption, you will be having a question. Okay sir, adsorption andre ಏನಂತ ಅರ್ಥ? ಲಿಕ್ವಿಡ್ ಅಥವಾ ಗ್ಯಾಸು ಬಂದು ಸಾಲಿಡ್ ಮೇಲೆ ಕೂತ್ರೆ ಅಲ್ವಾ? ಲಿಕ್ವಿಡ್ ಆರ್ ಗ್ಯಾಸ್ ಕಮಿಂಗ್ ಅಂಡ್ ಅಕ್ಯುಮುಲೇಟಿಂಗ್ ಆನ್ ದಿ solid surface, it is called as what? Adsorption. If a reverse happens, the reverse means andre artha not solid ಮತ್ತೆ liquid gas ಮೇಲೆ ಕೂರೋದಂತ ಅಲ್ಲ. Reverse ಅಂದ್ರೆ ಅರ್ಥ ಏನು? This is coming and accumulating ಆದಾಗ adsorption ಅಂತೀವಿ ಅಲ್ವಾ? ಅದೇ liquid ಅಥವಾ gas is being removed from the surface of the solid. From the surface of the solid. ಇಲ್ಲೇನಾಯ್ತು, ಲಿಕ್ವಿಡ್ ಅಥವಾ ಗ್ಯಾಸ್ ಬಂದು ಸಾಲಿಡ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಬಂದು ಕೂತಾಗ ಆ ಪ್ರೊಸೆಸ್ ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? adsorption. Remember, AD, adsorption. In the similar scenario, if liquid or the gas are getting removed from the surface of the solid, do remember it is called as what? Desorption. It is called as what? Desorption. What is happening? If liquid or the gas is coming and sitting on the solid surface, the process is called as an adsorption. If the come and sitting part has been removed, that is, a liquid or the gas has been removed from the surface of the solid. Remember, from the surface of the solid, it has been removed. It is called as what? Desorption. Of course, now both the words are including common word which is called as what? Sorption. An important part, of course. What do you mean by this sorption? So it's a phenomenon. Remember, mark my words, in which both your adsorption and absorption taking place simultaneously, which takes place simultaneously, alva. At a time, if both the process, that is your adsorption and as well as your absorption takes place, that phenomenon will be called as what? As your sorption. Okay, so what are the new terms we have listened over here? First and the foremost thing is your adsorbent. That is what? A solid surface on which the process of adsorption takes place, it's called as what? Adsorbent. What does you mean by adsorbate then? It's a liquid or the gaseous species which gets accumulate on the surface of the solid is called as what? Adsorbate. Coming with respect to that of your desorption. Of course, in case it's a process of removal of your liquid or the gas from the surface of their adsorbent. Alva? Process of removal of liquid or gas from the surface of an adsorbent is called as what? Desorption. Of course, then what do you mean by a sorption? It's a phenomenon where both your adsorption as well as your absorption takes place simultaneously. You can ask me, sir, where does this absorption takes place in our day-to-day life? Have you seen it? Of course you have seen it. Let me go with my first example itself. Take your white sponge and you just dip it in your blue colored solution. Let it be there for some few minutes, okay? Then you take out your sponge. What we could see, if this is your sponge, the outer part of the sponge has been colored with the blue color. You try to squeeze this sponge. What do? You try to squeeze the sponge. Of course, when you squeeze it, what happens? Water droplets comes out. Alva. So what has happened? Adsorptionally, blue colored particles has been adsorbed on the surface. In turn, what has happened to the water molecules? They have penetrated inside the body of the sponge. So this is a process where we can see or we can define sorption. So at a time, both your adsorption as well as your absorption, okay? Adsorption as well as your absorption has taken place simultaneously. So that is called as what? Your sorption. Now the question arises that what is the main difference when we are seeing as an adsorption and an absorption? Alva. Adsorption and an absorption. Please don't say so, it's just differences between the spellings. It is not the difference. So first and the foremost thing, let us see what we have studied till now. We came to know what your adsorption is a surface phenomenon. Alva. So whatever this process is taking place is only at the surface of the solid. So ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ಬೋದು, ನಿಮ್ಮ adsorption is a surface phenomenon. Whereas in absorption, what you can say, it is a body phenomenon. Alva, it's a body phenomenon. Inside ಕೂಡ penetrate ಆಗುತ್ತೆ. Whatever the molecules are there, in absorption process ಆಗಬೇಕು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, surface ಮೇಲೆ ಕೂಡ ಇರುತ್ತೆ, ಸರ್ಫೇಸ್ ಒಳಗೂ ಹೋಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಇಟ್ ಇಸ್ ಅ ಬಾಡಿ ಫೆನಾಮಿನನ್. ಓವರ್ ಆಲ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದೀವಿ ನಾವು, ಅಲ್ವಾ? ಇದು ಯಾವ ತರ ಅಂದ್ರೆ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್ ಅಂದ್ರೆ ನಮ್ಮ ಬಾಡಿ ಸ್ಕಿನ್ ತರ, ಬರೀ ಸ್ಕಿನ್ ಮೇಲೆ ಬಂದು ಕೂರುತ್ತೆ. ಅದೇ ನಮ್ಮ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್ ಅನ್ನು ಓವರ್ ಆಲ್ ನಮ್ಮ ಬಾಡಿ ಸ್ಟ್ರಕ್ಚರ್, ನಾವು ಬರೀ ಸ್ಕಿನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಕ್ಕಾಗಲ್ಲ, ಓವರ್ ಆಲ್ ನಮ್ಮ ಮೇಲೆ ದಾಳಿ ಮಾಡುತ್ತೆ. ಆ ರೀಸನ್ ಇಂದ ಏನಂತ ಹೇಳ್ತೀವಿ, ಅಬ್ಸಾರ್ಪ್ಷನ್ ಇಸ್ ವಾಟ್? ಅ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್. ಅಬ್ಸಾರ್ಪ್ಷನ್ ಇಸ್ ವಾಟ್? ಇಟ್ ಇಸ್ ಅ ಬಾಡಿ ಫೆನಾಮಿನನ್. Something else we can see, of course. What are those? So here the concentration on the surface is more. Concentration on the, that is the concentration of your gas or the liquid, that is your adsorbate, on the surface is more than the body. Whereas here what you can say? Yes, here the concentration is uniform. Concentration is what? Uniform throughout the body. Uniform throughout the body. ಅಲ್ವಾ? ಒಂದು ಸ್ಪಾಂಜ್ ನ ನೀವು ನೀರಿಗೆ ಹಾಕ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, ಎಲ್ಲಾ ಇಡೀ ಬಾಡಿಲೂ ಕೂಡ, ಇಡೀ ಸ್ಪಾಂಜ್ ಅಲ್ಲಿ ಕೂಡ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ದಿ ವಾಟರ್ ಕಾಲ್ ಬಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್, ಅಲ್ವಾ? ಸೊ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಸ್ ಯೂನಿಫಾರ್ಮ್. ಯೂನಿಫಾರ್ಮ್ ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಸೇಮ್ ಅಂತ. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಸ್ ಸೇಮ್ ಥ್ರೂ ಔಟ್ ದಿ ಬಾಡಿ. ಆದ್ರೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಏನಾಗ್ತಾ ಉಂಟು, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಸ್ ಮೋರ್ ಓನ್ಲಿ ಆನ್ ದಿ ಸರ್ಫೇಸ್ ಕಂಪೇರ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ body. This is the most important thing, the third important point. Remember, your adsorption is an exothermic process. Your adsorption is what? Is an exothermic process. Do remember, adsorption is an exothermic process. Hagadre artha enu? Heat is liberated. Whereas when you are coming with respect to the absorption, do remember, it is neither exothermic, nor it is an endothermic. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? ಅಬ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್ ಆಗತ್ತೆ, ಹೀಟ್ ಇವಾಲ್ವ್ ಆಗೋದಿಲ್ಲ, ಗೇನು ಆಗೋದಿಲ್ಲ. ಆದ್ರೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಆದಾಗ ಏನಂತ ಹೇಳ್ತಿದ್ದೀನಿ, ಐ ಆಮ್ ವೆರಿ ಮಚ್ ಪರ್ಟಿಕ್ಯುಲರ್, ಇಟ್ ಈಸ್ ಅನ್ exothermic process. That is, heat is liberated. Example wise, if you ask me, of course, instead of writing it as a point, let's take an example. What you can see, silica gel. Silica gel adsorbs your water vapor. Silica gel. Whereas in this part I can give as an example of anhydrous calcium chloride. Anhydrous CaCl2 alva calcium chloride. It absorbs the water vapor. So anhydrous calcium chloride it absorbs the water vapor. Whereas your silica gel, what does it do? It only adsorbs the water vapor. Whereas your anhydrous calcium chloride, it absorbs the water vapor. So this is the main difference when you are dealing with that of your adsorption and an absorption. Adsorption, as we have studied, it is only the surface phenomenon. Whereas absorption is a body phenomenon. Coming to that of your adsorption, concentration is only more at the surface than compared to the body. Whereas in an absorption, concentration is uniform throughout the body. Most important point in adsorption, remember your adsorption is what? Exothermic process. Whereas that of your absorption, neither it is exothermic nor it is endothermic. Coming towards your example, silica gel. Do remember, silica gel is going to absorb the water vapor, whereas that of your anhydrous calcium chloride, organic chemistry first chapter where by taking this example, anhydrous calcium chloride in organic chemistry, yes, you have to just recall it. It is going to what? Absorb the water vapor. So main thing what we have learned over here, so your adsorption is a process of what? Accumulation of your liquid or the gas on the surface of the solid. So that process is called as an what? Adsorption. So in this adsorption, whatever the solid surface we are choosing, it will be called as what? Adsorbent. The solid surface in which the process of adsorption takes place, it is called as what? As an adsorbent. Whatever the liquid or the gases are coming and accumulating on this surface of an adsorbent, that is called as an what? Adsorbate. Adsorbate. Of course, in case whatever the adsorbed particles are there, that is getting removed. Adsorbed particles are getting removed adaga, that process is called as what? Desorption. Both your adsorption as well as your absorption, AD and AB, both are taking place simultaneously. That will be called as what? Sorption. These are the important technical terms one has to remember when we are going to go further in this chapter. Let me ask you a question. If charcoal, C-O-A-L, charcoal adsorbs chlorine gas. Now can you please say me which will be your adsorbent and which will be your adsorbate? Yes. 3 seconds for you. So now adsorbent yaudilli? Charcoal. Yake charcoal? Because it is the solid surface we have taken for our adsorption. What is about your adsorbate? You can just see here now accumulation is your chlorine gas. So adsorbate inagutilli your chlorine gas. Important terms, don't forget it. The solid surface is called as an what? Adsorbent. The liquid or the gaseous molecules which is coming and sitting on the solid surface, that is called as what? Adsorbate. Okay. So guys, now when the question arises, so of course you have taught us what do you mean by an adsorption, what do you mean by an adsorbent and an adsorbate, but can you explain us why does this adsorption takes place? Of course I have said many times, science means it's a question. So if your question is why does this adsorption takes place, of course we have a theory for it. Of course you have seen it, but you have to understand it. For example, we know what adsorption means. What? It is taking place on the surface of the solid. So our main concentration will be on a adsorbent. So of course when we are choosing a solid surface, or simply if I state of your solid part, of course what do we know? In solid the molecules are what? Closely packed. What is that? Molecules are closely packed, yes, in this way. Yes. So this is your solid surface or an adsorbent. So if I will ask you the question that why we are saying all the times that in solid the molecules are closely packed, what is the reason? Of course you would be saying me, it is because to the mutual interaction, alva. So in martha unto the downward molecules is trying to pull. It is going to attract all its neighboring molecules in a very closed manner. Alva. That means what? Whatever the molecules which are present at the interior of this system, yes, please mark my words, the molecules which are present at the interior of the system is equally attracted in all the four directions. You can only see it. Although mid molecule ಏನೆಲ್ಲ unto, they have been equally attracted by its neighboring molecules. But now when the question arises whether the same force exists on the molecules which are at the top, of course not. Why? You can only see, of course, now this molecule if I choose, okay, it is going to attract from this side, it is going to attract from this side, it is going to attract from this side. But what about on its surface? Alva. So the molecules which are present on the surface, they are having some residual force. They are having some residual force. E molecules they are always in a time is needed for them. They're always in a position that they want something. They want something in order to balance this residual force. ಯಾಕಂದ್ರೆ ಈ ಫೋರ್ಸ್ ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ದೇ ವಿಲ್ ಬಿಕಮ್ ಮೋರ್ ಸ್ಟೇಬಲ್. ಹೇಗೆ ಸ್ಟೇಬಲ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. So of course ಈ ಪಾರ್ಟ್ ನ ಅರ್ಥ ಆಯ್ತಾ, the molecules or the environment of the energy of the molecules which are present on the surface is different from the molecules which are present at the interior of your system. Alva. So what does these molecules do? What is the different environment these surface molecules are having? They are having some residual force. So in order to balance this residual force, what they try to do, whatever the gas molecules or whatever the liquid molecules which will be present, they try to acquire it. They try to accumulate it. So when such accumulation takes place, what happens? This residual force will be liberated in the form of what? Energy. So what we can say, there will be decrease in the surface energy. What I am marking my words, during adsorption there will be a decrease in the surface energy, and that decrease will be appearing as what? Heat. Heat ಏನಾಗ್ತಾ ಉಂಟು? It is getting liberated. That is the reason we have stated in our distinguishing part that your adsorption is an exothermic process. Of course we know lesser the energy, what happens to the stability? More is the stability. So what happens? So when such liberation of the heat takes place, the part or the system becomes, or your surface of the solid becomes somewhat stable. And that is the reason we are saying as what? Your adsorption is an exothermic process. That during adsorption, whatever that residual force is there, that is getting liberated, or in simple words, the decrease in the surface energy is being seen as the form of heat liberated. And we know that whenever a heat is liberated, that process is known as what? As an exothermic. So when we are seeing certain thermodynamic parameters, let me ask you itself the thermodynamic parameters. What would be the sign of your enthalpy factor? Yes, since our adsorption is a exothermic process, we know that delta H will be negative. Yes. Can you please say me what will be the sign for your delta S? That is your entropy change. If you are not remembering entropy, let me remind you. It is the measure of your maximum randomness. Alva. We know that gas molecules delta S will be positive. Yake? Because the molecules are going everywhere. They are in a random motion. They are very free to move. Alva? That is the reason we are saying for a gas, delta S is highly positive. But during the process of adsorption, remember this thermodynamic parameters is considered for your adsorption process. And we have seen that during an adsorption, the delta H is negative. What can you say for delta S? ಏನಾಗ್ತಾ ಉಂಟು ಇಲ್ಲಿ ಗ್ಯಾಸ್ ಅಥವಾ ಲಿಕ್ವಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅವ್ರದ್ದು ರ್ಯಾಂಡಮ್ನೆಸ್ ಕಮ್ಮಿ ಮಾಡ್ಕೊಂತ ಉಂಟು. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? ದೇ ಆರ್ ಗೆಟಿಂಗ್ ರಿಸ್ಟ್ರಿಕ್ಟೆಡ್ ಅಲ್ವಾ? ಸೊ ಡ್ಯೂರಿಂಗ್ ದಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ the freedom of the movement of the molecules are getting restricted. That is, your entropy is decreasing. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? delta S is also negative. Please mark my words. So during an adsorption, when we are seeing the change in the enthalpy, of course it's an exothermic process, which means it is negative. Similarly, when we are seeing the change in the entropy, remember, it is also negative. The most important and the interesting factor now lies over here. Do remember your adsorption. Your adsorption is a spontaneous process. Your adsorption is a spontaneous process. That means what? It takes place on its own. It does not want any means. If you are taking some solid surface and you are adding some, if there is some liquid or the gas surface, of course the process takes place on its own. So what you can say, adsorption is a spontaneous process. Of course, what do we know? If any process which is spontaneous, the Gibbs free energy should be negative. Now the question arises over here. What is that? Of course, we were knowing that for a spontaneous process, the delta H should be negative, whereas delta S should be positive. But what is happening in adsorption? Of course, delta H, the change in the enthalpy is favorable. But what you can with respect to the entropy, it is not favorable. But also this process is called as what? Spontaneous process. Now the question arises, how? So when I am seeing the equation delta G is equals to delta H minus T into delta S, do remember during a spontaneous process, of course we are getting this delta G as a negative. Why? Because whatever the energy which will be liberated, what will be the energy will be liberated, that will be very high. That will be very high when compared to very high, we can say negative value. Very high negative value compared to the product of your T into delta S. Or in simple words, I could just say that your enthalpy factor and your entropy factor are balancing each other. What they are doing? They are trying to balance each other in such a way that your delta G should get negative. That is the reason your adsorption process is a spontaneous process. But if we go individually, remember your delta H is always negative to your adsorption process. That is, it's an exothermic process. Whereas delta S is also negative, alva, because the movement of your gas or the liquid molecules, once they get adsorbed, they get restricted. So once the randomness decreases, what happens to the entropy? It also decreases. But this adsorption being a spontaneous process, how can we explain? During the spontaneous process, the delta H value is highly negative when compared to the value of minus of T into delta S. This delta H value ಏನಾಗಿರುತ್ತೆ? It will be having a very high negative value when compared to that of your minus of T into delta S. So overall ಆ ಥರ ಆದಾಗ ಏನಾಗುತ್ತೆ? ನಿಮ್ಮ delta H ಮೇಲಿನ ಏನು ಸೈನ್ ಇರುತ್ತೆ ಅದೇ ನಿಮ್ಮ delta G ಮೇಲೆ ಬರುತ್ತೆ. So that will be in turn getting a negative sign. Of course, we know whenever your delta G is negative, it will be giving you what? A spontaneous process. Please do remember. So delta G for an adsorption, if any times in any competitive exam they ask you, do remember that. What is the sign for your delta G? Of course, delta G of an adsorption is always a negative phenomenon. If someone asks you that why does this adsorption takes place, here is your answer. whatever the molecules which are present on the surface, remember, on the surface, they're always having some residual force. In order to balance this residual force, the process of adsorption takes place in order to become stable by liberating the energy. Hence we say that your adsorption is what? An exothermic process. Please do remember here one important note is there. As the adsorption process goes on continuing, now the question arises whether it will stop at some time. It doesn't stop. Instead, it will be attaining an equilibrium condition. So as the adsorption goes on, what happens means your delta H will become less negative. Adsorption process initial ಆದಾಗ ಏನಾಗಿರುತ್ತೆ high negative ಇರುತ್ತೆ, but as the adsorption process ಆಗ್ತಾ ಹೋದಂಗೂ ಏನಾಗುತ್ತೆ ಆ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಆಗ್ತಾ ಬರುತ್ತೆ. ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, this delta H value will get equal to that of your T into delta S. ಅವಾಗ ಏನಾಗುತ್ತೆ ಡೆಲ್ಟಾ G ನಮ್ಗೆ 0 ಸಿಗುತ್ತೆ. ಸೊ ಈ ಒಂದು ಟೈಮ್ ಅಲ್ಲಿ ಏನಂತ ಹೇಳ್ಬೋದು ನಾವು, at this state your equilibrium state has been attained. ಸೊ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗ್ತಾನೆ ಉಂಟು ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮ್ ಅಲ್ಲಿ ಒಂದು ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಆ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಯಾವಾಗ ಬರುತ್ತೆ, ಯಾವಾಗ ನಿಮ್ಮ ಡೆಲ್ಟಾ H ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ T ಇಂಟು ಡೆಲ್ಟಾ S. ಈ ತರ ಆದಾಗ ಏನಾಗುತ್ತೆ ಡೆಲ್ಟಾ G 0 ಬರುತ್ತೆ. ನಮಗೆ ಗೊತ್ತಲ್ವಾ ಡೆಲ್ಟಾ G 0 ಬಂದ್ರೆ that will be called as what? Your equilibrium condition. An important part one has to remember. So in this overall part, what did we see that why does your adsorption takes place? Of course, the answer is in order to decrease that of your residual force. What happens when there is a decrease in residual force? That decrease in the residual force is being eliminated or liberated in the form of heat. So when such heat is liberated, what happens? We will be saying the adsorption process is an exothermic process. So when we are seeing certain thermodynamic parameters during this adsorption phenomenon, of course, delta H will be on negative, whereas that of your delta S is also negative. Why? Because whatever your gas or a liquid molecules are there that are getting accumulated on the surface of this solid, that is, the movement of the molecules are getting restricted. So when the moment or the randomness decreases, delta S also decreases. But considering these 2 points, the important point one has to remember that adsorption is a spontaneous process. Why I am saying it is an important point? In order to say adsorption is a spontaneous process, we should have known that delta H should be negative, whereas delta S should be positive. But in adsorption, what is happening? Delta S is negative, but also your adsorption is a spontaneous process. How come? It is only possible because whatever your delta H value is there, that is whatever the amount of the energy is liberated, that is having very high energy, that in terms very high negative value. So this negative value in turn balances the overall equation in such a way that your delta G should get a negative. Once the change in the Gibbs free energy is negative, of course the process will be your spontaneous process. So these are the important part one has to understand in the concept of your adsorption. So overall in this video, what did we learn? Your adsorption is a surface phenomenon. So in adsorption, we are taking an adsorbent, that is a solid surface, and an adsorbate, that is your liquid or the gaseous molecules. Yes, of course, there are 2 phenomena which will be leading to our confusion, that is an adsorption and an absorption. So you have to remember that your adsorption is only the surface phenomenon, whereas your absorption is what? It's a body phenomenon. When the question arises that why does this adsorption takes place, it is mainly because of the residual forces of the molecules which are present on the surface of your solid. Mark my words, because of the residual force of the molecules which are present on the surface of this solid. So in order to balance this residual force, what is happening? The process of adsorption takes place. So what is happening when this accumulation takes place? The energy is getting liberated. That is the reason we say as what your adsorption is a exothermic process. Coming with respect to that of your change in the entropy, of course during an adsorption it is also negative. But your adsorption is what? A spontaneous process. Your delta H is balancing in such a way that your delta G should get a negative value. So when does this delta G gets a negative value, what we can say? Your adsorption is a spontaneous process. The question when arises that whether it is going to continue, of course it is not going to stop, but it will be attaining an equilibrium condition. And how does that equilibrium condition is obtained? As the time proceeds and the adsorption process continues, your delta H will become equal to that of your T into delta S. So at that period of time, the delta G will be equals to 0, and that time your process of adsorption has attained an equilibrium condition. So in our next video, we are going to see different types of your adsorption.